Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We're working on the second spell of our game here called Aqueous. We're shooting water and that's what we've got so far. Now we've got it to where it's shooting in the right spots, right? It gets blocked by collidable map objects, so it can land only in legal spots. So that's all looking good. What we don't have is enemy integration, you know, so if we try to shoot the gecko with it, nothing will happen. Even though I can't aim it like that. There's a couple things I'm thinking about doing with this spell. The biggest one being if we go up to the volcano area, which is not made just yet, but in the volcano biome, there's going to be fire enemies, and the water is really effective against those guys, right? So you got to basically transmute them from the fire corruption to fire cleanse, or, you know, cleanse of corruption via water for the magma enemies. But then also, if you use water on something that isn't a fire, it should still do something, right? It shouldn't, I mean, it could either be totally non-effective at all, or, which, you know, I'm always for the including more interactivity. So the water spell should do something different for normal enemies, whether it be slow them down, so that, you know, there might be a better use. Like, it might be better for you to just come over here and do the flame on these guys. But if you get the water should do something, right? It should do something. So I'm thinking if against any enemy, or against, well, yeah, I don't know. I guess against any enemy it should slow them down, but if it's a fire enemy, it should slow them down and make them flee. So that's what we're going to try to do, you know, the startings of today. So I'm not sure how effective that's going to be, because what we're going to do is probably quite complicated with something like a particle system for a different state on a gecko. So let's say a gecko has a different state called splashed, for example. If they were splashed by the Aqueous, they become splashed, and if they're splashed, their walk speed is 70%. You know, they slow down a bit. They have maybe a blue tint to them, or a blue flashing to be like, hey, they were slowed down, so they're in a nerf state. And then obviously all the collision detection stuff, so that we can actually detect a hit and everything. So we get to decide how to do these things. The easiest would probably start with, I kind of want to say it's going to be, let me see, actually, let me see. We can turn on, yeah, let's just turn on some rendering here in the Aqueous projectile so we can better see what's happening. And okay, so right here we have this area where we're kind of checking, you know, this is where the spell would land if we cast it successfully. So we have a boolean on our spell called, or on our projectile called casting. You know, it's like if we're actively casting. That doesn't get turned off until all the frames have played once. So what we can do is check, if the element is casting, then let's go ahead and cycle through all the scene's collidable entities, check for collision, and potentially change their state. So we have to make a new state for the entity, which would have things like modifications to the walk speed. It'd have maybe a blue tint or a blue flash to indicate the nerf, as well as a timer to reset them back to normal. So let's I'm thinking that the easiest way to detect collision is going to be with this green square we've got, because this is the value of which we're tweening the projectile to land. So that if, basically if we're casting, we're going to check, hey, is there an entity colliding with that square at all throughout any time during the cast? Before the animation gets fully played out, we check for that collision. So I think that'll be good. Okay, so let's take a look at what that collision really is. It is a modification of our nearest tile column and nearest tile row. We don't need the X offset for the AABB collision, so what we're really just going to be checking is this nearest tile column and row. So let's see how we would go about potentially making this new state for the geckos. It's very similar to the walk state. It's just that instead of... Let's look at what the walk state is for the geckos. So there's a gecko walk state, and if we're corrupted, we're going to be checking our health. We're going to basically modify our walk speed right here, or modify our position based on our walk speed. So there should be like a default walk speed we have. It might be in the entity defs. Let's check entity defs here. Where is it? Okay. We're looking for geckos here. Trying to see if we instantiate them with a walk speed. We might not define them or give them a base one, but when we go in our map declarations, we might be putting them in. So let's see that. If we can go to our map declarations and see when we instantiate an actual gecko, we do initialize with a walk speed here of random, as well as AI path of random. So it looks like upon spawn they get a random walk speed, but if we look at the random, it's just this random divided by 100 times 60. So I guess we're just nerfing the random a bit for a specific range that is just slowish walk to fastish walk for at least these guys. So I don't think we're reassigning this, so this is a good thing to modify for the other state, like splashed state. So we should make that. Let's make our gecko splash state, and it'll be very similar to the walk state. We don't necessarily have to split it up into two states here, because we're going to be reusing so much of the walk, right? Which is what's your AI path, what's your direction in relation to the player, all that tracking, as well as collision and stuff. I mean, if we look at our walk state, let me see. We don't do any collision in the state machine, so we must do that elsewhere in the play state or something. Okay, but still, there's a lot of stuff here that we're just going to have to reuse if we make a different state, when we could just have a substate of the walk state, because most of the logic is the same, just the walk speed is different, and a potential rendering blue or a flashing. So I'm kind of thinking we do this and just say, well, let's just modify what a splashing gecko would look like, which is flashing blue, maybe a little particle system to drip water off of him or something. All of the corrupted particles kind of float to the top, so maybe nerf particles can sink or something like that. But let's just get that working, like where we're happy how it looks, and then we can actually trigger it upon the collision with a successful cast. So maybe for now we'll start with the blue, right? And we're doing this in the walk state. We're saying, hey, let's grab our animation, let's just draw him at its own location, at its current frame. So before we do that, there might be a modifier. So the modifier might do something like just set a different color for the render so that we come out a little more blue. So a Love.graphics set color, and instead of setting it to white, maybe we do red, green, and blue. Just set it to a completely blue 100% alpha channel before we draw it. And this is just, for every gecko when we're in walk state, just to see if it looks okay, or see how it looks. So see, they get blue like that. It's probably too dark, but we can't do much more about the brightness for that. Minus pump up a little of the red and green channels so it's not so dark, because this will add the brightness, a little more brightness. Let's see. I don't think it needs to necessarily look amazing, but yeah, I kind of like the blue. I kind of like the dark blue like that. Let's keep bumping it up just a bit. Maybe we do 120. You know what? Let's try 150 each, but maxed out on blue. Okay, looks a little more purple, so let's split that difference. Yeah, let's go back to 120. Let's see that. Okay. It doesn't look blue enough for me. We could brighten up. We can brighten up the purple sprite, which I think we will want to do at some point. It doesn't bug me. It's just that when we go to, because in this manner we're not doing a different sprite. We're just changing how we render the purple. So since the purple's so dark, there's only so blue we can make it. But if we do a flashing, it could be easier to read the blue. So let's see what the flashing might look like if we do 75, and then full on the blue channel. So let's do this flashing. So in our walk state itself, we have a flashing bool that is not necessarily false, but also a flash timer. And we're just gonna increment that flash timer. Flash timer gets modified by delta time here. And then if our flash timer is greater than, let's say, 1 second, then we've got to swap our bool, which is flashing. So we could do a ternary operator here. There's no pretty way to do a ternary in Love, I don't think, but we could just say, oh, you know what? No, we could do it. Yeah, we could do it easy. All we have to do is say flashing gets assigned not flashing, right? So just get the opposite of what the bool is and assign it to that new value. So flashing will become on and off every 1 second, hopefully, as long as we reset our flash timer back to 0 before we start incrementing it again to catch this greater than 1 here. Yeah. So if we're flashing, now we're going to do this where instead of just willy-nilly rendering it blue, we say, well, if we're flashing, then go ahead, render it blue, which is this. Otherwise, just do, why can I not? Love.graphics, set color, and we have a value for this already, white. Okay, so if we're flashing, we're blue. If we're not flashing, we're white. And right now we're just gonna be toggling flashing, hopefully, in the walk state. So let's see that. Okay. Yeah, it needs to be much faster than 1 second and hopefully brighter. I don't think we can do much on the bright aspect. I really don't think we can, unless maybe, let's see if, like what, maybe 100 out of 255 looks like. It probably won't be very colorful. I wonder what happens though. Should be brighter, right? With lower? No. The brightest way to get it is just full 255, which is white. So the brightest we can get is the darkest the purple looks. So I don't like that aspect of it. But what we could do, we could just make the geckos a neutral color and tint them purple before we render, or tint them blue. That might be easier. It's still a little weird to make the original gecko none of the colors it's supposed to be and just tint them on their state, but games have done weirder things, I'm sure. Let's see what that 100 looks like, and on the flash timer I want to set that to whatever the threshold is, right? I want to be maybe 0.4, 0.3. Let's see what 0.3 looks like. So this is 100 out of 255 on the blue channel, so let's see what that looks like. Yeah, it needs to be brighter. 0.2. For right now, I don't think we'll worry about getting the blue like perfect. But as long as we have the things to start tweaking the blue, it gets us a good jumping point for when we want to be more perfectionist about it. Okay, so something like that. Yeah, like flashing blue. Right, and maybe it just tints the particle system. Because if they get sprayed with water, like with this guy. Uh-oh. Yeah, I wonder if it'd be nice if we could track the projectile. Well, I don't know. It's like, part of me thinks that we should do collision for just the projectile, like the actual ball moving, or just the green zone, which is where the ball's going to land. Because if they're in front of you, the ball should hit him. Yeah, like that should hit him, even though it wouldn't have, because he was past the green square. So we should also check the ball's trajectory and just be a little more lenient with that check. This is fine though for now, because like it's clear to me that it's flashing in like a splash zone, and we didn't have to duplicate any state machine and reuse a bunch of code. We just modified the walk state to also hold the flashing status. So maybe what we can do now is see if we can tint that particle system to be blue, being a secondary visual cue. Where is the particle system on the entity? I don't know. We should have a particle system on the entity, but I don't know when we initialize that. Let's see in the map declarations. They're not added here. Maybe it's under the gecko class or the entity class, maybe. Is there a particle system? There's a particle system in the entity, okay, of about 400, and here's where we're doing it. Okay, so right here there's a dot particle system on the entity, and it is a set colors, and it's a range of colors. I forget it's like a starting value and an end value. So this is mostly a dark value favoring red, and then it goes to mostly a purple value that is transparent. So that's what these values are all in here, and we can modify these values by this. So we might want to be able to save these values in a variable so that we can just say, oh, set color to default gecko color, or set color to splashed gecko color, and not have to worry about all these numbers and stuff. I don't know if we can just pass in a table and have it interpret it. We could certainly try. Because yeah, we can try. I know we can do it with white. That's what we're doing. But I don't know about 2. This takes in 8 params, so I don't know if we can. I don't see why we wouldn't be able to just do it. I don't see why. Let's try it. Whenever we define our enum for white or whatever, where is it? Constants, maybe? Where do we do it? We set white right here. Yeah, it is in constants. Okay, so let's try this, where we're gonna say this new value we're putting in here is gonna be this. So just like how our white was assigned to 4 values in a table, this is going to be gecko, and this is for the particle system, so gecko splash particle color. And for right now, it's technically just going to be the purple gecko. So this is going to be gecko corrupted particle. Okay, and there's no different than the splash just yet, but we're just trying to see if we can put the variable in there. So instead of setting color to this, we're going to change what's inside the parentheses here and make it gecko. What did we just change it to? Gecko corrupted particle. Gecko corrupted particle. Okay. So I'm hoping for no difference here, just purple particles coming out. Great. So we can change the color here. Let's test what the blue color is supposed to be. It can be something similar, right? Where it starts as a dark color, but then it fades to a light blue. So the splash particle can start at the same dark, but red, green, blue, let's say there's more blue, right? So closer to 200, and maybe a little bit of green as well. And let's see what the splash particle is, because we want to do a splash particle here to see what that blue particle's looking like, and then we can tether it to the flashing bool in the walk state. The particles do not look blue. Let's try something a little more in your face. Red, green, blue. We're just gonna say nothing, but start fully blue, fully opaque, and then fade to mostly blue. So let's try that. Should be a little more clearly blue. Okay, yes. I like that. Okay, it is way too blue, but it's looking much better. Let's try 100 on the brightness. Well, 100 on the blue channel. Yeah, I like that. It is definitely different than the purple. So it's like when it's when it's chilling there, it does a couple. Oh, actually, yeah, it doesn't do purple because we don't switch it. But we have the two variables here. So now what we can do is say, yeah. We start with the corrupted particle. But we're going to go dig into this particle system on the entity itself and change the method. You know, we're going to run the method set colors on our P system and change it to the splash particle, not corrupted, and or back to corrupted if we're cleansed or not cleansed, but no longer splashed. So in our gecko walk state, we're setting the color of the, basically before we render the gecko, the entity, but we have access to that self.entity, and we need to run the self.entity.p system. We want to run that set color method with set splash particle, and then we need to set that if we're flashing, but if we're not flashing, we can try to set it. And it's like this really wouldn't get set here. It gets set upon becoming unsplashed, basically, but we don't have that just yet. So gecko corrupted particle whenever we're not flashing. So if we're flashing blue, particle's blue. If we're not flashing blue, particle's purple. It happens too fast, but I think it's working. And hold on, I saw there is a weird, there's like a one frame where it goes, where the spell cast is wrong in the top left there, but let's slow down. We should have a bool for this threshold, we call it. So this can be, we can literally do this local flash speed. And we're going to say, let's go back to 1 second so that we can see it, and then just do the conditional with flash speed. It looks all blue to me. The particles look all blue to me. Well, this is okay. This is okay because we shouldn't do it upon flashing. We really shouldn't. We should only do it upon being flashed, basically. So like once we become flashed, once we assign this, yeah, it's like yeah, we should have a bool to trigger the active splash state. So we'll have splashed or not in our walk state, and it'll be splashed. And it's kind of weird. Like, do we put this on the entity or do we put it in the state machine for the entity? I don't exactly know, but what we could do is just do this where we say, for right now, we only want to do this flash timer if we're splashed, because we don't want to be flashing if we're not splashed. So if we're splashed, then go ahead, do that flash timer. Okay, so if we're not splashed, flash timer never will increment, and then if flash timer never increment, we don't become flashing. We just need to do another thing here, which is to initialize a splash, and we can do that in many ways, like splash timer. Just for now, for testing, right? Splash timer, just to trigger the splash. And we could say, regardless, we're just gonna assign our splash timer to increment. We could put this on a key button press if we wanted to, but actually we have to assign this to be equal to plus delta time. That increments it, and then we can just say after 3 seconds, then we're just gonna flip this bool of splashed. So self splashed becomes true after 3 seconds. And then if we're splashed, we're gonna start to flash. And then the color render for the particle system is here in the render. We set the color. It's like in the render. Does it make sense to do it in the render here? We don't want to do it here. We want to block it sooner. Do this. Yeah, we don't want to do it here. We want to set this in the init as corrupted particle, right? So in the init, we say, you know what? Yeah, we start as corrupted. But then if we go to splash, that's when we need splash particles. So once we become splashing true, or splashed gets true. So right here at the splash timer, we're changing that to be blue particle instead of purple. Okay, let's try that. It should be a little more apparent now that it starts with purple. See, look, it's still blue. The splash flash looked right, but the particles looked wrong the whole time. So what, if we don't do this splash particle, is it still blue? It's still blue. What the? We must have had the same thing. No, corrupted particle is the purple one. Can we not set colors of a particle system once we've initialized it? That might not be how it works. But why is it blue? If we're setting it to corrupted particle here, why would it be blue still? That's what I don't get. Gecko splash particle. We set the particle system in the init on the walk state. So it's, hold on. Why is it blue? That's what I want to know. We're setting the color somewhere and it's not the same purple anymore. So where did we change that? Corrupted particle. For corrupted, we put corrupted particle. Okay. Gecko corrupted particle. Yeah, that's the same one. Just for the peace of mind, I'm gonna try to do it the way we had it and just see. Because there might be a weird thing where we can't. Like we can't change a particle once it's been made. Like we have to clear the particle if we want to change the colors. I don't exactly know how it works, but for right now I'm taking this out because why is it blue? That's what I want to know. It should be the same color it used to be, which is purple. Here we go, purple. Okay. So this isn't working. This corrupted particle value is not working. No, it's looking purple now. What the fuck? Okay, it's looking purple, whatever. Let's see when it flashes. If it flashes, does it start looking blue? Purple, purple. After 3 seconds, we flash blue. And still purple particles. While we turned it off. So here in our gecko walk state, we're just gonna say, if we're splashed, go ahead and set the color of the particle system to be the splash particle, which is blue, only after that 3 seconds. So purple, purple, that's looking right. And then flashing blue. Does it become blue particles? No. I don't see blue particles. Gecko splash particle. Okay, well, the last thing that fixed this was omitting the freaking constant here and trying it manually. So let's just try it manually. Not in the corrupted particle, but in the splash. Where's the splash? Right here. Okay, let's try this. Self entity P system. Set colors. And we'll set it like that. Okay, purple particles. Let's see, we're gonna flash blue here. And no blue particles. Right? Yeah. God damn, why is it so hard? Do we have to clear the particle system? Set colors. Yeah, we're setting it to the super blue one. We do set it anytime our splash timer is greater than 3. Yeah. I don't know why we can't change the color I've never tried to change color of a particle system mid update, you know? So it might have something to do with that. Let's see. Love2d particle system color change. Let's see. Set colors is the most common way to create dynamic color transitions. Yeah, that's what we do. If you want to change the color of an entire particle system similar to tinting, you can use set color before calling draw on the P system. This multiplies the particle systems by the global color to keep them looking exactly as defined in set color. Make sure to set the global color back to 1,1. Okay, see, look at this. White base texture. Yeah, that's what I'm thinking. Because this is why our geckos are being so dark. The particles will stay that color till they disappear. I guess I still don't get, like, if you could set it while it's happening, while the particles exist, and change any new particles coming out, because that is not clear to me. Because they're saying, well, like, the set colors is kind of the one over time. Right, we give it those are the 8 values we give it is 4 values of the starting color, 4 values of the end color. So if we're setting color after it's already been created, well, the particle's been created, it might not work like that. I see what they're saying though with them, keep it white so you can tint it, but it doesn't look like it's tinting it. It looks like it's just totally jacked up. Like it's just not changing. Oh God, they just get out of my. Splash particle. Yeah, we're gonna, let's just say it's absurd and fully white. I just want to see a difference when it's flashing to know that we can change a P system once, you know, do a set colors once the P system's active. See, I don't see any difference in color from the particles there. It's not good. I just want the particles to be brighter. They're not doing that. And it is kind of weird. I mean, this is in the update, so the entity particle system, that should be right. Entity dot particle system set colors. Okay, and that's how we're doing it for the other color set, right? Where are we setting the color here? I'm looking for that gecko walk state where we assign it actually, because I'm not even seeing where we assign it. Right here in the entity. Oh. Okay, so we're just resetting it here. Okay, so this should be easy. We don't want to set the color here anytime we're corrupted. We want to just set it upon the init. So corrupted particle for right now, we don't set the particle color. Here in the entity, we set it in the walk state, or in the idle state, we can set it, right? Because it's like, this can be initialized like this, but it can't be here. If it's here, it does it every frame. We need to find where we initialize this particle system and hopefully put it in there. So it can have it before it's even in the walk state. And it looks like we do it here in the gecko. At least with here. We initialize it, what, in the entity. So once the entity is created, so can we leave it? You know, an entity has to get initialized because it's a class. So can we do it just after we have that entity? Yeah, where would we put this logic? Because just because it's a entity doesn't mean it gets a particle system that's purple. You know, so do we do it once we insert an actual gecko? See, it's kind of like this. It's like we need an initialization for this entity, because that's what we're kind of doing here. If we're corrupted, we're going to go ahead and do all that stuff. Otherwise, we're just going to update. Yeah, it's like we need to do this in the init. Let's just do this in the init. For the entity, I guess. Instead of the update, yeah. So if it's a gecko, we're going to do this stuff. And we're going to set the corrupted particle color here instead of in the update. Because where we were, yeah, we were doing it every frame because we were corrupted. And then in our walk state, we're still going to do this. It's not here in the init, but in the splash timer, we're going to say, well, and for right now, if it's a splash timer, it's going to look hella white on the particles. which is okay. We just want to change the colors of them. And it's white already. Is it white if we turn that off? Because we weren't even at the splash timer. Still white. Okay, so where did our purple corrupted particle go? Because it should have been right here in the entity init. It should have been here where we say if it's a gecko, we init that corrupted particle color. So where did the freaking white come from after we deleted this? I want to try to put back the corrupted particle here just because I don't know where that white was coming from. We're looking for colored, not white here. Oh, I just saw it switch. Hold on. So it was possible to switch colors amidst the particles being activated, because right there, once we become flashing, it goes back to purple. So if we're splashing, it went back to purple, but we're still setting it to white. Let's see where we're doing that. P system dot actually colon set colors. And we're doing it here. Corrupted particle. See, it should be right. That's why it shouldn't be white. But it is still white. Oh. Okay. It just must not, this init, it's got to be wrong. Does set colors need to be set over time? Like in the update? It can't just be initialized? I don't know. But we're only ever setting the color to purple, and that's working. But setting it to, we should set it to purple by default and set it to blue if flashing, but that is just not happening right now. The init was init right here. If the type is gecko or a gecko C, we're gonna go give those animations of the gecko and then set. Yeah, this should be on the entity, which has the particle system, right? Because the P system, yeah, we have it here. If type is gecko. Okay, so let me just see. Does this get us purple back at least? Yeah, it gets us purple back. But this sets it every time. It sets it every frame, which then when we go to tinted blue, it doesn't work. So tinting purple after initialize worked, but not turning it to purple on the init, that didn't work. So we need to find a way to initialize this color outside of this update so that we can render particle, or we ask if we're flashing in here, or splashed. So if we're splashed in the update, then go ahead, render the blue. Otherwise, just render the corrupted particle color. So that should get set anytime here. This should work. Let's see, we're looking for purple. It looks purple. Once we flash, It's not changing to blue, is it? God damn, why can't we change this thing? If we're splashed, we should be here. Oh, splashed isn't part of the entity, it's part of the walk state. Shit. But we have an entity here called .entity, so we can put the splashed on the entity. So entity splashed is false, and then if the whatever self.entity splashed gets true, if self.entity splashed. Okay, let's try that. Because yeah, splashed is not on the entity. Come on, blue. Come on, blue. Yes, yes. Finally, blue particles. Okay. Okay. Does this make sense? Does it make sense in the entity to be checking if we're splashed and set the color for the particle? Sure. We couldn't get initialization colors to change. I don't know based on what order of operation that was failing, but we can change colors with a variable here, which is nice. And we're triggering it upon a splashed field on the entity itself now, which is good. We don't initialize it anything. We should probably initialize it as a default no. So we're not splashed by default, because right now we're only, oh my gosh, splashed, and because we only really kind of like this was kind of a hack. I mean, you know, not a hack, but we didn't have a splashed boolean on that entity, but we went into that entity's table of splashed key, changed it to true without initializing it. So it worked, but you know, we should probably init it false, so we're not just like creating it. Well, I don't know why. It just feels like we should. Okay, so we're changing to the corrupted particle. If we pass that splash timer right now, it's okay to leave it like this, I think. We could do, I don't know if it makes sense to make the particles with the flashing instead of the splashed. Let's see what it looks like. I don't think the particles should change with the flash. Let's just see how it looks again. Okay, blue and flashing. Great. Cool. Let's go back to fast flashing, so that whatever that flash speed was, let's go back to like 0.2 or whatever, and it should be a lot faster. So boom, we splash him. He's flashing blue. He's got the blue particles now. So now we just need to modify the walk speed when they're flashing, as well as revert their flashing after 30 seconds or whatever. But it is my bedtime, so let's check. Let's do a get diff here and just clean up anything we might need. Yeah, let's turn off Square Magic Land from our aqueous projectile real quick. Actually, we can do aqueous projectile Square Magic Land. Yeah, we'll turn that back off. Okay, and then yeah, let's do get diff. Okay, we added a splash field to our entity. Initialize it false. And then in our reset original position, we do set color back to the corrupted particle, which is fine. Oh, you know what? I think that's why it wasn't. I think that's why it was white on the init. Because we only set the color upon the reset original position. So if we would have walked off screen and come back, let's see. We set the color of the particle system to be related to the splash field on the entity. We give us two variables to control this blue or purple particle. And then we added a bunch of little fields, which we can take out some of this, like the corrupted particle in our gecko walk state. So let's just do that real quick. Yeah, I just don't want these lingering around when they're not doing anything. So let's do that again. Okay, we got the corrupted particle. We got a flash speed, a splash field. And then for flashing, we're rendering blue or white if we're flashing every 0.2 seconds. That's what our flash speed is set to. Okay, I think that's good. So we're going to add and commit with a message saying that we add splashing field on geckos with blue flashing while splashed. All right, git push it. Okay. Tomorrow we will be integrating the collision with the spellcast so that we can actually do something. Other than that, we'll continue chugging along on the game. If you are interested in playing the game or wishlisting on Steam, you can hit up steam.tashio.dev. Otherwise, we will find someone to raid here and call it a night. Thanks for hanging. I'll be back tomorrow. We'll get more work done on it. Internet willing. It's been about 2 days of the week where my internet actually has upload speed good enough to stream. So I try, but sometimes Xfinity literally just will not stream at all. I'm gonna hit up Jedum. We'll hit him. Thanks for watching. Peace out.